Hello everybody, welcome. Today I want to talk about the third conic section in our series. I want to talk about ellipses. So get yourself some paper and some pencil because thinking and writing should go together. And let's get started. But before I do anything about ellipses, let me talk about the conic sections just kind of in general. We'll lead up to it. So at this point you should be seeing my little document camera here. All right, so we talked first about what a conic section is. Conic section is the shape that you get when you cut a cone at various places and in various ways. And the first conic section was when you cut a cone just parallel to the base there. If you can see that, you get a circle. All right, so then the next one was what you would get if you cut a cone parallel to the side. If you can see the edge of that cut, say right here, and then the edge of the side along the top, you can see that that's parallel. Those two surfaces or cuts are parallel to each other. And then you get this shape here, that's the parabola. There we go. All right, so now the third one that we want to do is I want to do the cut that you get when you do a cut that is less than the angle of the side. You get this shape here, which is kind of at a bit of an angle because it's sitting there. You get this shape here, which would be an ellipse. And so let me develop that then by doing this little exercise. I've got my grid space here, my Cartesian grid space, and I've got my my super duper compass. And I'm just going to draw a circle. We're going to build our definition of an ellipse off of the definition of a circle. So the circle is the collection of all points equidistant from a center point. And so if I draw this, then you saw me do this perhaps on the earlier video. If I draw this, the string controls the distance that the blue pencil makes. And so here's my basic circle. And so all of the points that are on that circle are equidistant then from the center point. I can come up here with a ruler and check that. That looks like that's a little bit right at about 9 centimeters, maybe 9.1 centimeters. So if I come over to this distance right here, oh look, about 9.1. If I come over here to this side, let's go to 9.1. See, are we on the edge? Yeah, we're on the edge of here. So that would be then your simplest definition of circle. And so the equation, the Cartesian equation for that is the simplest thing because it's just the distance is equal to a fixed number. But what happens if I were to introduce a second center to this? Well, if you think about it, the distance, the diameter from the very top edge here all the way down to the very bottom edge here vertically would be the same on a circle as it would be from the side edge to the side edge over here. But if I put a second center point in here, let's make it maybe about halfway between right there. And you say, what do you mean by a second center point? Well, I'm going to put the string around here. And now I'm going to draw this. Do you remember what shape this one is? Yeah, there's your ellipse right there. Whoops, it slipped. Rats, even the string slips. Let's see if I can darken this up a bit. Okay, there we go. Now, that's an ellipse. You're looking at it and you're like, no, it looks like a circle. Well, okay, there's a way that we can check that, right? We said before that the distance top to bottom was the same as the distance side to side with a circle. Do we have that now with this thing? I don't know. Let's find out. I'm putting the edge over here and I'm measuring in centimeters. This looks like it's about 13.6, 13.7. 13.7 left to right. Now let me go top to bottom. Let's see if I can get it in here. I may have to remove that one because it's in the way. I really do want to do right down the middle. So right down the middle, what do we say it was there? Oh, look. Do you see how far down this one goes? This one doesn't go down quite as far. It's like right at 13.1. What was the side to side? I go from the edge to edge, 13, there's 13.5, more than 13.5. And then if I go top to bottom here, more than 13.5? No, look, there's 13.5. Less than 13.5. But to the casual observer, it's so nearly circular that it looks like a circle. You'd have to really kind of maybe make some measurements there to figure out that it wasn't. All right, let's extend this one now on even farther. This is the second center. Let me put it like way over here, almost to the edge. So now I have two centers that I have to keep track of. Get my string in there, push those in tight. All right, so now here we go. Comes around like, whoops, did it slip again? Nope, I'm just not putting full bearing pressure on it. There we go. I don't want to pull the pins out, but here we go. Okay, there. Now, is that an ellipse? Most of you would now say, well, yeah, that looks elliptical, okay? But notice I had to move these 2 points like almost to the very edge then to finally get a shape that looks elliptical. And let's just double check. All right, so side to side, it looks now like it's about between 10.5 and 11. So that's going to be, I'll call that 11.7. And then top to bottom here, down through the middle, the highest point down through the middle looks like it's about 8, if you can see that. Okay, so yeah. The distances then are not the same left and right and top to bottom. Sorry about the gnat that's there on the page. All right, so if we take the center point and we merge it into 2 and then separate them, we get this then elliptical shape. In fact, the reverse is true. If you were to take these 2 focal points now, these are called foci, if you take these 2 and you merge them closer and closer together, you get closer and closer and closer to a circle. There's a concept later on, we're not going to do it in this lesson, but there's a concept later on called eccentricity. Eccentricity, eccentricity. No, wait, that was electricity. Schoolhouse Rock days. But eccentricity is a measure of how circular an ellipse really is. And ones that are almost circles have got a very close eccentricity to, I think it's 1, if I remember right. And then ones that are really kind of squashed and flat have an eccentricity that's closer to 0. It's been a while since I worked on that. Maybe I got those backwards. You could look it up and figure it out if you wanted to. That's why when Copernicus was doing the motions of the planets, and he put the sun at the center and put the planets in order out from the sun in order of the amount of time it took for them to make one full cycle, and the Earth was the 3rd in that list. Mercury was the closest. He made them in circular orbits, and then Kepler comes along and he says, oh no, they're ellipses. But Kepler did math for years to show that they actually were exactly ellipses, because even the most elliptical orbit of the planets, which I think was at Neptune at that time, that was the most outer planet. I mean, it might have been Jupiter back in that. Jupiter, there were only 5 that were known to the ancients. But the orbit is so nearly circular that it takes some really fine-tuned and accurate measurements and patience with the math to show that it's actually ellipses. So the orbit of the planets is not elliptical the way you would see it like this. It's not even elliptical the way you would see it like that one. It's so nearly circular that it's very difficult to tell them apart. It takes them very precise math and patience. Had to wait hundreds, if not thousands of years to sort that out. What new things are some of you going to do that we've thought were true for a long time, and you're going to say, no, just slight variation on that? Okay, but in order to have people that think like Galileo and Copernicus and Newton, we should be training them in how they thought. Being patient with mathematics is one of those things. All right, so let's switch over now to the notes. So here we go, the ellipse. A couple things. First off, every ellipse has a center. And it's not the 2 points. The 2 points there that I measured the distance from, those are called foci. So this is a focus. Let me zoom in here. This is a focus. And this other here is a focus. And the plural is foci with an I. But now the center of the ellipse is in the middle of these. So let's see here. If I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 right here. 16, 17, 18, 19, 20, 21, 22. All right, so come back to the left one. I'm going to count 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If you look carefully, I already had like a little pin bother. Right there would be my center. Okay, now a focus, as we talked about, is longer on one axis than it is on the other one. This long axis has a name, and we're going to do this one first. The longer one should always be the first one that you do. Let's see if this is enough. So I'm going to come through the center here and join the focuses or the foci. Oh, come on, right on the end, on the end, on the end, on the end. I can't get it quite on the end. Okay, this right here is called the major axis. Oops, too fat. Let me back it up. Thinner point to right. Major axis. Okay, the other one from the top to bottom on this particular ellipse is, can you guess? You can probably guess. Goes down through the center. That's the, if it's not major, what is it? That's the minor axis. Okay, now let's go back to our equation of a circle. The equation of a circle, and don't write this down, just watch. I'll give you the equation for the ellipse in a second. The equation of the circle was something like this. It was x minus h squared plus y minus k squared is equal to the radius squared. What would happen if I took this circle and I divided everything through by radius squared? Divided by radius squared, divided by radius squared. This over here would change into 1. That's not normally how you write the equation of a circle, but it gives us a starting point. Remember that x goes left and right and y goes up and down. And if they're both divided by the same number, r squared, if their expressions are both divided by the same thing, then your distance top to bottom, the diameter of the circle top to bottom, is going to be the same as the diameter of the circle left and right. But if they're not the same, guess what you get? You get an ellipse. Because look, the major is longer. You can call the major axis maybe the horizontal diameter in this one, and you can call the minor axis maybe the vertical diameter in this one. Not the same. So when you do the equation for an ellipse, it looks very similar to this equation for the circle that we've got here, except the following. It's going to be x minus h squared plus y minus k squared equals 1, but now it's going to be divided by two different things. We'll call the first thing an a squared and the other one a b squared. Not the same. That means your distance left to right is not the same as your distance top to bottom, and that will give you then an ellipse. Okay, so let's talk about what these things are. The book's going to give you, if you're looking at a textbook, the book's going to give you two different formulas. Again, I'd rather you not have to memorize two slightly different formulas and be able to manage all the memorization adjustments that have to go through. I'd rather you think. I'm always going to write it with the x first here, and then the y in the second spot here. And I'll always write it with the a below the x and then the b below the y. But here's the thing. If your major axis is horizontal, then that's going to be the number, the larger number goes under x. So if it's a horizontal one, the value below the x group is going to be larger. And that's what we have for this one over here. If for some reason you had, and you will, if for some reason you had an ellipse that was like this, it was longer on the vertical axis, this then would be the major axis right here. Then the value underneath the y would be the larger one. And so if you're looking at a textbook, it will swap those a's and b's. And they'll say, oh, for this one, the a goes under the y, and for the other one, the a goes under the x. Like, don't memorize, think, okay? Whatever the denominator is, the larger denominator tells you which direction the axis goes. If the larger denominator is under the x, it's wider horizontally. If the larger denominator is under the y, it's longer vertically. So the general form that I'm going to use is just going to be like y's and the x's and the y's there. I'm trying to get rid of the little dots. Okay, so you should commit this now to memory. It's basically the same thing as a circle, except when you divide by the radius, it's different for the x's and the y's. All right, so now let's get back up into this. Let's talk about now what the major and the minor axes are. So this, if we go back to just the major axis for a second, I just want to look at the major axis. The distance from the center to either one of the edges, this distance right there, that's your A. Okay? So the overall distance end to end from here all the way over to there, 2A. Okay? Now, the endpoints of your major axis are called the vertex. You've got two of them. You've got a vertex on the left and you have a vertex on the right. These are the points. Okay? Your center, believe it or not, guess what that is? That's just going to be your HK. But where does your focus sit? Your focus is over there a bit. Let's come back and let's talk about the focus in a minute. Let's now not talk about the major axis features. Let's talk about the minor axis features. So let me erase this and here and there. And erase that, erase this, here and that. Let's talk now about this minor axis, which is going to be the short diameter, if you want to call it that. And it's going to go like this. Okay, the distance from the center to either end is a B distance. That's B. And the distance then from top to bottom all the way is 2B. Or not 2B? No, it is. It's 2B. Okay. Now, these points here are also vertices, but they are not called direct vertices. They are called, the top and bottom points are called co-vertex. The co-vertex is the endpoints of the minor axis, called a co-vertex. Okay? Now, let me come back now and talk about the foci. So let me erase this, that, and that. And let me now do another major axis, and I'm going to do it in black. I'm going to go from one end to the other one here, all the way through here. Okay. This distance now from the center to one or more of the focuses, or foci as they are properly called, that distance is a C. So we've got some A's and B's and C's going on here. The A involves the length of your major axis. It's the distance from the center to the vertex of your major axis to the left or the right, or the top and the bottom if you have a vertically oriented one. B is the distance from the center to a co-vertex, which gives you your minor axis. And then C is the distance from the center to a focus. Now, a focus always lies on a major axis. Okay? Focus cannot lie on a minor axis. Focus always has to be on the major axis. Now, you need to memorize this. C squared is equal to A squared minus B squared, where this is, C is the distance from the center to the focus. Now, it looks like the Pythagorean theorem, but it's not. It's a minus in there. It's based on the Pythagorean theorem, if I remember right, but the A's and the B's and the C's are different side lengths, and so to make them fit this, it's somewhat slightly different. Don't get hung up here, though, on A's and B's. Remember I said A is always the larger one, no matter where it sits in the equation. Your A is always the distance from the center to the edge of the major axis. So whenever you're doing the mathematics, this has to be larger than the B. Okay, why is that? Because when you take the square root of this and the square root of that to find out what C is, you can't take the square root of a negative number. And if you make the front thing, the A here, if you make that the smaller one, it won't work out. And we'll do some practice here in a minute, so just be patient. This is what we need to know. We need to know major axis, minor axis, vertex, co-vertices, and we need to know A, B's, and the C's. The C is the distance from the center to the focus. Okay, let me look at my notes here. Have I talked about everything? I talked about this, talked about that. Yes, 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 did that. Yeah, 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 did that, did that, did that. Yeah, I think we're right on track. Okay, so good now. Let's try this. Find the center. Let me see if I can get the other one out of the way. Find the center, vertices, co-vertices, foci, major and minor axes in the equation of the ellipse. Holy smokes. Okay, so the first thing I'm going to do when I look here is I'm going to find the center. It's already drawn for me. So the center is going to be in the middle of these foci. The foci are labeled F1 and F2. So where's the middle? Looks like that right there. That's my center. Okay, so the center is this point now. What is that? -2 up 3? -2, 3. There we go. Already got the first thing. Okay. Now notice that this is a vertically oriented ellipse. So this distance from here all the way down, that's going to be my major axis. So this is a vertex here, the point on top and the point on bottom. So the vertices are the points. What is that? -2, and then oh, wait a second. I'm not looking at the scale. It wasn't. Oh no, I'm right. I'm right. It was. What is that? 2, 8, and then the other vertex is going to be the point. -2 goes up by 2s. It goes up by 1s, but they're only writing 2s. The other vertex is down here at the bottom, and so that's -2, -2. Okay. So I'm done with this one. Done with that one. Co-vertices. I'll do those in blue. Those are going to be on the minor axis. Here's the minor axis. Always goes through the middle. It's the shorter one. And so the co-vertices are going to be the point over here on the left. What is that? -6. And then the y value is 3. And then also +2, 3. Are you noticing that the vertices share the same x value, different y values, and the co-vertices share the same y values, different x values? Be thoughtful on that. So we did the co-vertices. I'll save the foci for the end here. Okay. The major and minor axes. Well, the minor axes, since I have this here in blue, the minor axis is going to be the distance from this end on the left to this end on the right. So all the way across. I'm going to count the units. 1, 2, 3, 4, 5, 6, 7, 8. Minor axis is 8 units long. Okay, which means that it's going to be now half of that is going to be my B value. Half of that, this distance right in here, that's 4. This is the answer to the question. I'm going to save that number though. Major axis. Distance from top to bottom. I'm going to count the grid lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, can I do that now? Oh, I remembered a tool that I have. Look, I've got a little laser pointer. So I'll start here and I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so there you go. Now I can count and you can actually see it. The major axis is 10 units long, which half of that gives me my A. That's going to give me the distance right in here. That's 5. Okay, and I'll save that. But this is the answer to the question. So I've got the major, minor axes, and the equation of the ellipse. I'll do the foci last. Let me do the equation of the ellipse. The equation of the ellipse, remember the format, is going to be x minus h squared plus y minus k squared is equal to 1. But then we're going to have a number down here squared, and then we're going to have a different number down here squared. Now, looking at the ellipse, it's a vertically oriented ellipse. So my the up and down corresponds with the y value. So my denominator for my y value now is going to be the bigger number. So technically that's my a. If you want to go back through here, you will be like, oh, that's your a squared and that's your b squared. Okay. It doesn't matter if you memorize that, but I want you to be thoughtful about it so that you can reason your way through. All right, so now what is the center? So it's going to be, where's the center there? 2, my h and k up here at the top. Negative 2, 3. So it's going to be x minus a negative 2 squared plus y minus 3 squared is equal to 1. And now, what's the major axis length? 10. Take half of that, 5, and square that. So down below the y value is going to be 25. And then take half the value of the minor axis, which is 4, and square that. Down below, that's going to be 16. So here then is the equation for the ellipse that you see right there. And now let's do the foci. I want to actually show you where the foci are once we get in here. So let me pick, let's do it in purple. Remember, I need a C value now for my foci. So the C is the distance from the center to the focus. So C squared is equal to A squared minus B squared. So C squared is equal to, take the bottom one here, the bigger one, 25, minus the other one right there, 16. And then what do I get? I get C squared is equal to, what's 25 minus 16? Oh, look at that. Is it 9? 9. So C is equal to 3. So if you look here, look at this. I'll do my laser pointer again. Look here. If you go from C, or on the center, you go up 1, 2, 3, there's one focus. And if you start here and go down, 1, 2, 3, there's your other focus. So this distance now is 3. So if I do the points, I'll do them over here on the left-hand side. Focus 1 is the point, then it's going to be the x value of negative 2, and then it's going to go up 3 units from the center, which is going to be 6. And the other one, F2, I just realized I did a double F, that should be a 1. Focus 2 is going to be down 3 units. So that's going to be negative 2, 0. Okay, so there we go. I've put all of the pieces together, and there's the equation. It's kind of involved, and it's going to take some practice for you to sort out logically. Is it longer left and right, or is it longer up and down? Which one's the major? Which one's the minor? What is a vertex? What is a co-vertex? What's my A distance? What's my B distance? All that sort of stuff. So give yourself some time and give yourself some patience and work through it. Learning is work, so got to make sure you do the work of learning. I think we're done with this one. All right, so let's go over here now to the next one, example number 2. This one's now just a description. Major axis 8 units long, parallel to the x-axis, minor axis 2 units long, and center at negative 2, negative 5. I'm going to draw myself a picture. So I'm going to draw like just a little Cartesian grid here. And I'm going to start with the center that I know. So the center is going to be negative 2, left 2, and then down. 1, 2, 3, 4, 5. There's my center. This is my H, K. Now, what else does it tell me? It tells me the major axis is 8 units long from end to end. And it's parallel to the x-axis. Well, the x-axis goes left and right. So if it's parallel to the x-axis, it's going to have to go this direction right here. Left and right. But how far? It said 8 units long. Well, that's end to end. So from the center, I'm going to go half of that right and half of that left. So my major axis now goes to the right. 1, 2, 3, 4. So there's 4 units that way, and then 4 units back that way. Okay, and the minor axis is 2 units long. The minor axis now has to go up or down. Half of 2 is 1, so it's going to go up 1 and then down 1 like this. And so what I get is this, this really kind of a bent, sort of a, pardon my crude drawing here, this really kind of a bent ellipse that goes that way. But I can see very clearly that it's wider on the x-axis line and narrower top to bottom. So my value below the x group in my equation is going to have to be the largest one. Okay, so then what do I need? I need my A, which is the larger one. A is going to be half of the major axis. Okay, so that's going to be 4. My B value is going to be 1. I got enough information now to write my equation. So it's going to be x minus h squared plus y minus k squared is equal to 1 over something squared over something else squared. And now let me put the pieces in. So it's going to be x minus a negative 2 squared plus y minus a negative 5 squared is equal to 1. And now what are my denominators? Well, it's wider on the x, and so that means my a is 4. And down below I have to square that, so that's going to be 16 here. And the other one has to be the 1 squared, so that's going to be 1. So right there now, that's my equation. What is c? Let me find c here. C squared is equal to a squared minus b squared, where it's all a is always the larger of the two. So that I get c squared is equal to 16 minus 1. So c is equal then to the square root of 15. Look, this one didn't come out to be an integer. You're going to have to deal with decimal approximations when you graph and non-integer values there for your foci. Okay, so let's now do, I can do my vertices. So vertex are going to be on the end of the major axis. So if I have the point here, which is negative 2, negative 5, that's my center, and I go 4 units to the right, my vertex is going to be positive 2, negative 5, this point right here. And the vertex is also going to be 4 units to the left. So negative 6, negative 5. That's this point over there. Alrighty? Now, covertices. The points now I'm going to go up 1 unit for each of those. I'll do those in red. So if I go up 1 right here, the first covertex is going to be negative 2, and then up 1 from negative 5, negative 4. And then the other one's going to be negative 2, and then down 1, negative 6. So those are my covertices. Now, foci. Foci are going to be interesting. Let me see if I can squeeze in here and show you what I mean. Let me see if I can erase some of the clutter. That line. Let's go back to the original ellipse kind of sketch here. Sorry, it's a little bit warped. The right side's longer. But if I go in here now, the foci have to sit left and right of center. And how far left and right of center? The C unit, this distance right here, has to be the square root of 15. So on both sides, also the square root of 15 over there. So my foci then are going to be the x value of negative 2, and I'll go to the right first, plus square root of 15, whatever that is, that's the exact value. And the y value is going to be negative 5, and negative 2 minus square root of 15, and then negative 5. So that then are all my pieces. Oh, major and minor axis. So major axis is going to be 2a, so that's going to be 8 units long. Oh, wait a sec, did they tell us that? Yeah, they told us that in the problem. Okay, I'll just copy down again if you want to. Did I get everything? I think I got everything. Whew! Okay, now let's do one more. This will be the last one. Write the equation for and graph the ellipse. Okay, now this one's not in standard form. I'm going to have to complete the square. You guys did this before when you did things with circles and even with parabolas a bit. So let me go over here. I'm going to go to the right and do my algebra over here. So let's change over to blue. And I'm going to group the x's together. So it's going to be 9x squared minus 36 as a group, and then plus the y group. The y is going to be 6y squared plus 12 as a group is equal to 12. Okay? Now, let me work with this just a little bit. I'm going to have to complete these squares, but I need a leading coefficient on x squared and y squared of 1, which means I'm going to have to factor out the 9 and the 6. Let me show you what I mean. The 9 is going to come out of the x group, leaving me an x squared minus 4x. Looks like I forgot an x right there. Sorry. Probably forgot a y right there. I did, didn't I? So leave space. Okay. Now, plus, factor the 6 out. 6 times the y package, y squared plus 2y. Leave space equals 12. Okay. Now I have to complete the square. So, look at the b term right here, 4. What's half of 4? That would be 2. Square that and add that in right here. So I would be adding in plus 4. But what do I do now to the other side? It's going to be plus something. What do I do? It's not going to be plus 4 because I didn't really add in plus 4. I added 9 times positive 4, which is 36. So if I added 9 times 4 to the left side of the equation, I need to add in 36 to the right side. Okay, now do the same thing for the y value. What is half of 2? Okay, that's 1. Square that and add that in right here. So that would then be plus 1. But if I'm going to add plus 1 into the group, do you see that it's actually 6 times 1? So I actually added in 6 to the left-hand side. So guess what? I have to add in 6 to the right-hand side. So now let me collect all my pieces. It's going to be 9 times x minus 2 squared plus 6 times y plus 1 squared is equal to, golly, what was that? I did the math earlier. I want to double check. Yeah, that's what I thought. 54. It's convenient. 54. But that's not our standard form. I'm going to have to get the right-hand side equal to 1. How do I do that? I divide by 54 on the left and everything by 54 on the right, and you get some nice cancellations going on. So on the left-hand side, I'm going to get the 9 and the 54 that will drop and just give me a 6 down here. So this is going to be then x minus 2 squared over 6 plus. Here the 6 is going to cancel, leaving me a 9. So it's going to be y plus 1 squared all over 9 is equal to 1. There we go. There's the equation. Now, how do we graph it? Well, to graph it, all I really need to do is plot the major and minor axes, or even just the vertices and the co-vertices. Okay? So what I can see here now is this. I can see that my denominator under the y, the 9, is bigger than 6, which means it's going to be an ellipse that opens kind of up and down. Okay? Now, where's the center? The center is going to be HK, 2, negative 1. So let me come over here and I'll do it in red. 2, negative 1. Here's my center right here. Now, from the center, my major axis goes up and down, and the distance from the top and the bottom is 2a, which means the distance from center to the top or the bottom is going to be the square root of 9, which is going to be 3. Okay, so this is going to be 3. So I need to go up 1, 2, 3, plot a point right there. And I need to go down 1, 2, 3, plot a point right there. All right. So now I need to do the minor axis. The minor axis is the square root, or the b value is the square root of that. So b is equal to the square root of 6. That's hard to do on a grid since it's not a integer. So I'm just going to find a decimal approximation. The square root of 6. So square root 6 is probably 2.7. Yeah, 2.449. So b is approximately 2.4 Okay, so I need to go to the left. How far? I need to go to the left from the center. 1, 2, and about a half. So here's the left-hand side, and then go to the right. 1, 2, and about a half. It's about right there. So there's my top and bottom and left and right of the ellipse. Now, my advice when you draw these is to draw your end of your major and minor axis first, the little sweep. Notice where it's going to be a little tighter curve. If it's longer sideways, the curve's going to be kind of a little tight. And if it's not quite as long top to bottom, it's going to be kind of like, I don't know, a little bit shallower. So I need to do like a kind of a shallow kind of a curve left and right here. And I need to do kind of a more of a rounded kind of a curve on top and on bottom. And then you just kind of have to then get these things to meet. And it's going to be ugly at first. I just know it. It always is. But you should then be able to go back through and then erase and make it, that looks still kind of like a football. You have to go back through and work on it a bit. This needs to be just a little bit more curved out. Curved out. They should be symmetrical. Come on, curved out, curved out. You know, sometimes if you're doing it with a pencil, if you make your line kind of thicker and thicker and thicker and thicker, you can hide errors so you don't have to erase. But anyway, I can see that this point here is not symmetrical with that point there, so I got to erase those on the bottom there. And what does this one do? This one probably comes out and around a bit like that. And this one comes down and around like that, maybe. Well, that's the best I can do right now on that. Okay, so ellipses, the wrap up. Make sure that you understand major and minor axis. Let's go back up to the one. Okay, the major axis is always going to be the longest of the axes. It's always going to be from left to right. And so this one now, since the major axis is horizontal, it's going to, the larger denominator will be under the x. If it was a minor axis from top to bottom, the larger number would be under the y. Here's your equation that you should commit to memory. And you should also commit this equation here involving c to memory because you're going to need to find the foci from time to time. Okay, so this is very detail oriented. I want you to make sure that you understand the ideas and are able to build up what you need based upon what you're given. Sometimes you're just going to be given the major and minor axis lengths and the center, and then you got to work from there. Sometimes you're given the foci distance and the center, and you got to work from there. And so just be thinking about, what do I need to know and what do I know, and find the logical path that gives you what you need to know from what you do know. And as always, if you don't have a sketch helps. So draw a little picture, reason it out in your mind. And again, be patient. This is very detail oriented, but they're nice. I actually like ellipses. But anyway, so I hope you learned something. I hope you're having a great day. I hope you're pursuing happiness. And the pursuit of happiness takes wisdom and virtue. And mathematics is one of the things that can help us be wise. So have a great day. Bye-bye.